My camera had also cut, so please over here in the switch case, change the increment and the decrement values for the player movement component Vy and Vx to set it equal. Instead of decrementing it, set it equal to -1 and 1 where it needs to be. Once you do that, now that we have our square moving based on the user input, we want to actually put a sprite to the square, because a square itself is not very fun. That's not how a video game looks or feels, obviously. So we need to now add the sprite component to our system, to our game. So let's go to the component.js file. And here we're going to create a sprite component. And our sprite component is going to have 3 properties. The first property is going to be the sprite or the image itself. The next property is going to be the path to that image within our assets folder. And the third property is going to be the src rectangle property. And this property is going to tell our sprite component where on that sprite sheet are we getting that specific image, because if you've looked into the assets, you've probably noticed that we have some pretty big sprite sheets with multiple sprites on them belonging to different characters. So we want to get the proper image for the entity that we're trying to display a sprite for. So let's create this component. It's going to be class sprite component, following that pattern that we've set out before, with a component type and a component object. Remember to call the super for the component type. So this sprite, we're actually going to create a new, not a new sprite, a new image upon the initialization of the class. Then this path, we'll just call this path, is equal to component object path. And then this src rect is going to be component object src rect. And src rect is going to look like this. It's going to have the x, y, width, and height that we want to take from that sprite sheet. Let's not forget to export the sprite component. Now let's add this into the registry, or let's add this into this create entity method, I should say. We're going to follow that same pattern we've been doing. Const component object is equal to component value, new entity components, sprite is equal to the new sprite component. And now let's add this sprite component into the component requirements of our render system. If you remember before, I actually had mentioned that we would be creating this kind of component and that we would be adding it to the component requirements of render. So now we will go do that. Sprite. And also let's add this to our player component, or to our player entity, I should say. Let's create a dummy sprite component. Path is equal to assets. We're going to use the link PNG because we're going to be displaying link first. Then src rect. So where is link? We don't know this right now. I've already went ahead and done this research for you, so I'm going to plug in these values. But if you want to play around and find out where link is on your own, feel free to do that. But just know that's why I can easily plug these values in. So it's x58. And then we're actually going to put this at y-1 just because the spacing kind of looks a little bit better in my opinion. and the width is going to be 19, and the height will also be 19. And then assets are on the same level as the assets folder is on the same level as index.js, so we actually do not need to go up a directory. Let's add this into our player component. I mean the player entity. Let's console.log out the player to make sure we are properly adding this component. Let's refresh. Great, now we see the sprite here with all the values that we put into it. So let's go back. Now we want the render system to fetch this PNG file and then display the proper place on that PNG file. So let's go into the render system. Let's move up clear rect because actually it should only run once every update. Let's get the sprite path and the src rec from the sprite component. Then let's change this fill rect to draw image. This is how context renders PNG files. And we'll also need the image itself. And I just realized I actually need to set the image's src, its source value, to the path. So let me just do that. It actually won't be its own property. So now that we fixed that, we'll go back to the render system. We don't need this fill style either anymore. We can comment that out for right now. And we'll fill in the draw image method. Sprites. So the first four numbers are the destination that you want it to appear on the screen. So that's the entity's position. So X, Y, width, height. The next four numbers are the position that you want to, or the space that you want to take from the sprite sheet to display upon the screen. So it's the source of the image. So let's actually do another destructuring const, and we'll do this. Oh, I think I did this backwards. Oh no. There we go. That looks better. So source X, source Y, source width, source height. And let's see what we got. So we see we have an image here, but that's not exactly what we want. I know what I did wrong. So let's go back. I actually put this in the wrong order. Takes the source first and then the destination second. Okay, so now it should look better. Let's check. Perfect. So we have Link facing up. That's exactly what I wanted. If we move him, we can see this is our entity. And it's good that he can move. We want him to change directions when he's moving. So when he's moving right, he should be facing right. When he's walking, we should see his legs moving. So to do that, we're going to create another component. We're actually going to create another system. And this component is going to be the animation component, and the system is going to be the animation system. And this is where it gets a little complicated, so please follow closely. We'll go to component. And we're going to start with the pattern that we've grown accustomed to at this point. And our animation component is going to have quite a few properties, and it's going to be fairly complicated. So I'm going to write out some comments that clearly depict what each property is going to look like. So the first property is going to be a complex object called frames. And how frames is going to look, it's going to be a massive object that has the properties for each animation that Link will perform. It's going to have 4 main properties, all based on the directions that Link can face: down, up, left, right. And within these directions, we're going to have multiple properties in these objects. And these will be divided into 2 separate objects themselves: move and attack. This is because for every single one of the frames that Link can perform, they are located on different parts of the Link PNG. And I'll show you that right now. So as we can see, the movements for both attacking and running are very different. They're located at different places on the sprite sheet. And because of that, we need to specify where exactly they are located. So within each one of these move and attack values, there are going to be additional keys that are related to what specific frame Link is on, the source rectangle where we're actually going to crop the image from, the frame speed rate, and the start time of the animation. Current frame. So every frame, every animation is going to start at the very first frame. The number of frames in the animation is going to be 2 for Link running up and down. It's very simple. He just moves his feet one after the other, so that's easy. The frame speed rate, so we're going to see how this is used in a little bit. This is going to be used to determine the number of frames that we show per second. And then we have the start time, which is going to take a date now property because we're going to be tying in Link's animation to real world time. And then for the attack half of the direction, we're going to kind of replicate what it is that we have in move. But since attack has its own values, it has its own source rectangle, and we need to keep track of its animation frames as well, we're kind of replicating this. But it holds its own values, so it's mandatory. Frame. Very good. One last thing. Because source rectangle is going to contain multiple images, multiple frames, we're going to have an array of this kind of object. So really, it's going to look like this. So for example, down, this first object right here is going to be this Link right there in the corner. The second object is going to contain the coordinates for Link right here at this part of the sprite sheet. And in the animation system, this source rectangle, or we'll be looping through this source rectangle and alternating between these 2 links while the user is pushing the down button or the S button. Because this is such a large and complicated part, I've gone ahead and written this object out myself. That way, I can just paste it and it'll be very easy for you guys to just look at it once and copy it. So to avoid mistakes, I'm going to create a new file within a new folder called animations. And we'll just call this, we'll call it animations. So I'm going to create a constant, and this is going to be the link animation component. And I'm going to create this object now. So the name is going to be animation. The value is going to be an object. And this first property, the one we just went over, frames, is going to be this object that I'll copy and paste. I'm going to zoom out so you can get a good look at it. I'll start up at the top. Please pause this video and go through it. Please carefully copy it for links animation. So pause it where you need. I'm going to scroll down slowly. Good. Once you've done that, we'll add the other properties to link animation. But first, we'll finish up in the component class. So the next property that we're going to have is we're going to have the property called current time of animation. And this property is going to track how long the user has been doing the current animation. And the reason why we want to know this is because we're going to use this value shortly to determine which frame is the proper frame to be displayed upon the screen. So this current time of animation equal to component object current time of animation. We're going to be adding more properties to this class in the future, but for right now, let's just keep it how it is, and as we need them, we'll add them. Let's not forget it to add the current time of animation to the link animation object. We'll set it to 0 to start. Let's export this animation component. And we'll add it to the create entity function in the registry. And we'll add it to our player entity. I'm going to export link animation. And instead of creating a dummy component like the other ones, let's just simply import this link animation and then use it within our create entity function. Now that we created the entity using this component, let's check, make sure that it's actually within the entity. Seems like it's all there. Good. Okay. So our entity has this component. Great. Now let's create the animation system that'll utilize this component. Let's go into system. And we're going to create the animation system now. So class animation system. And we're going to follow the pattern that we've set up. System type, super system type. For this component requirements, let's put position, sprite, an animation, because I think anything that we will ever want to animate, we'll need to have these three things, because we can't animate something without a position. We can't animate anything without a sprite. And just because something has a position in a sprite doesn't mean that we'll animate it. Like a tile, for example. A tile will have a position in a sprite, but we will not ever be animating a background tile. Let's go to update. And now that we're in update, I realize that there is one more property that we should put into our animation component. And this property is the facing property. It will determine what set we should be displaying at any given moment. And since a character can only face a single way, we'll just put this at the top of the animation component. This facing will be equal to component object facing. Good. So now let's go back to our system. And what I'm going to do now is, or actually, you know what we need to do? We need to do a few things. The first thing is we need to change the character, change Link's direction based on what direction the user is pressing. So if the user is pressing W, for example, we want the player, we want Link to be facing up, and we need to change that property. So let's go to index, and let's go down to handle user input. So I'm going to go to the switch case, and first thing I'm going to do is I'm going to add brackets around these so we can keep the scopes very clear. It's always a good idea to do this. Let's go and check the facing property. So facing is going to just be a string. So let's get the animation component. And I'll follow the pattern I already set up. And let's change it based on what direction the user is pressing the button in. So player animation component.facing should be up, because W makes the player go up. A is left because the player is going left. Right, or down I should say, for S, because S is making the player go down. We will not change this on key up, so we don't need to worry about this portion. And let's just make sure this works. So I'll console.log player animation component facing to see if this is properly being changed. Syntax error. Let's see what we got. I didn't extend system. There we go. Good. So the direction is properly changing. We'll go back. And one more thing I'm going to add to our index.js if we're going to be working with the animation system. We need to now, in our game, start keeping track of real-world time. And we do this to keep our animations in line with time. How do we do this, and what are we doing? I'm going to add a property to our game class. We'll scroll up, and I will put it right in the constructor. And I'm going to set it to date now. And upon every update, we're going to update this value as well. So that way we have this value up to date at all times. And we're going to use this value in our animation. So let's go to registry. And in order to test our animation system, we need to first be able to add it to our game. Let me export animation system. We're going to pass a game time, so while I'm here, let me just put that into the updates arguments. Now we'll go to registry. We'll go down to add system. We'll add it, animation system, new system, new animation system with the system type. This registry add system is animation system. Let me make sure I didn't make a typo in here. Animation system. No, I think I'm good. And go down to update. And let's update this. We'll get the animation system and we will call the update function. And along with this update function, we are also going to pass it this game time, the property of the game. We're passing it in. And you're going to see it here, increment. Let's go to our browser and check. And there we go. We see game time. Very good. Let me get rid of this console.log. We don't need it anymore. And also, let me get rid of this console.log. We don't need the facing console.log anymore. Let's start writing out the update function of our animation system now that it's successfully in the game and it's working, or at least the update function is being called. First, let's loop through the entities. As of right now, we only have one entity. But later on, you may have enemies on screen. You may have static entities. Let's get the entity. Let's console.log him out to check. Make sure it's properly being picked up. Yep, we got him. Cool. We'll even check to make sure the facing property is changing. Very, very good. One thing I forgot to do, go to animations, go to value, and in facing, add up to start. Because we're planning to render Link facing up when the game begins, and we need to remember to add this property with that value into his animation component. Go back to system now. Now the first thing that we want to do is we need to know which direction we are animating Link in. If you look here, our object, the frames, the first level of properties are down, up, left, and right. So we need to know what direction we're facing in at the start. That's the first thing we need to know. So let's actually take that property out. So once we have facing, this is where it gets a little tricky, and we need to use a mathematical formula to find out which frame Link should be on if he's moving. And this is the formula. And we're going to put this value into a constant because this is going to be the current frame. And it looks like this. We're going to wrap game time minus entity components animation current time of animation. We're going to do that because we're wrapping multiple things in this math floor, because we do not want to get a number with a decimal. We just want an integer. And we need to wrap this because we need this operation to perform first. And then we're going to multiply by the entity components animation the frame speed rate. And we're dividing this by 1,000. Little typo here. And we're going to use the modulus operator, and we're going to go to the frames, number of frames. Let's console.log out the current frame, and let's see what we got. Not a number. So there was a mistake somewhere. I forgot to incorporate facing. Here and here. And also, there will be a difference between moving and attacking, but for right now, we'll just hard code move into this. Let's check it again. There we go. So you see that? It's alternating between the first frame and the second frame. This is going to give us the illusion that Link is actually taking steps while he's walking. Now that we have our current frame, let's apply this to Link. So we're going to get the entity components, and we're going to go into the sprite component now. And since this render system is using src rect from Sprite and using this information to render Link onto the screen, we need to change the current src rect values. So we're going to go into src rect, and we're going to grab the src rect that the render system should be displaying based on the direction that Link is facing, as well as the current frame of the animation that Link is on. So let's go in, components, animation. So it's frames, this frames, go to facing. So he's facing up, right? And we can look to our left and we can see this, using this comma, we can clearly map how this should go, how we can drill down into this complex object. Then right now we're using move, so I'm going to hard code that value in. And then we're going to go into src rect. And now that we're in src rect, let's go to the specific frame since we have an array here. So current frame. Let me save that. And then last thing we should do is we should set the current frame that the entity is on. Frames facing move current frame equal to current frame. And we're going to be using this value later. Let's see what we got. Now we have Link walking. However, even when we are not pressing the button like I'm doing now, we see Link alternating between steps. So we don't want him to be doing this, obviously. We only want him to be walking when we're making him walk. So this is a very easy fix. Let's go back into our VS Code editor. And we're going to add one more property to our animation component. And that property is going to be the should animate property, which is going to be just a Boolean flag. I'm going to add this value into our animations.js file. Should animate. We'll set it to false to begin, because upon render, Link is not going to be running. He's going to be stationary. And in our index.js, we're going to change this when the user is inputting one of these 4 keys. So should animate is equal to true. And importantly, when Link is not running, we're going to set the animate to false. Now let's use this value in our system. We'll pull it from here. Should animate. So if should animate, let's see if it worked. That looks good. Link is now running, but only when I press the button. Very nice. Now this looks good so far. I know in the future we're going to have enemies colliding with Link, and Link will be getting hit by the enemy and getting knocked back. We're going to have a knockback feature in this. To make that work, I actually want to just clean this up, and I want to put the facing values, the setting player animation component to up, left, right, etc., into the movement system instead. So how we're going to do this is using logic statements. If movement.vx is greater than 0, and we're going to pull the animation component out. Animation.facing is equal to left. If movement.vx is less than 0, animation facing is equal to right. Actually, I think this is inverse. I think it needs to be right and left. We'll check in a second, but I think that's correct. Vy animation facing up. If movement Vy is greater, animation facing is equal to down. Okay. Let's just console log out. Or no, let us just comment this out, actually. Good. And that refactor successfully worked. We'll go back to our VS Code.